am Dr. Sathya, working as a assistant professor in Department of Chemistry, SNS College of Technology. Today we are going to discuss one interesting topic, U visible spectra. That means the principle and instrumentation we are discussed now. So what is meant by UV visible spectroscopy? What is UV? UV means ultraviolet visible spectroscopy. In UV, we can't see in our open eyes. This is a very lower wavelength. That means 200 to 400 region. For visible spectroscopy, we can see. That means with GR, 400 to 800 nanometer. So this is UV visible spectroscopy. The UV is the wavelength 200 to 400 and visible means 400 to 800. So this is called as UV visible spectroscopy. So this is in UV visible spectroscopy, the light will be interact with the solution, and also the electron. When light enters into the solution, the electrons will be move into some ground state to excited state. The third point, the qualitative analysis. This is one of the qualitative analysis and also the quantitative analysis. So what is the principle of UV visible spectroscopy? Here one electronic transition occur. That means the solution will absorb the white light. The solution will be entering into the light. The electrons will be jump into ground state to excited state. That means N to pi sigma electrons. That means it involves the lone pair. The N means the lone pair of electrons. It absorbs the light. The lone pair of electrons will be absorb the light in that solution to move into the sigma band. That means ground state. And also N to pi star involves same the lone pair of electron and absorb the U visible region, and pi to pi star and sigma to sigma star. So the fourth transition occurs in the electronic transition. That means U visible spectroscopy. Beer-Lambert's law. So this is the main law in U visible spectroscopy. So what is Beer-Lambert's law? Incident light. That means the incident light will be passed through the solution. The solution will be absorb the light and transmitted into some radiation with the particular wavelength. That means the incident light enter into the sample and absorb the absorbance calculated and transmittance calculated, and finally the transmitted light, the light will be emit the sample. This is a Beer-Lambert's law. So in this Beer-Lambert's law, we can calculate from the incident radiation and also the transmittance radiation. That's called I by I naught. So in Beer-Lambert's law, we can call A is equal to epsilon CL. That means A is equal to absorbance. Epsilon is the molecular coefficient, C for concentration, L for the length of the cuvette cell. So here we are using an sample, no, that cuvette, that cell contain is called a cuvette. So that length will be 1 centimeter. So the absorption of the solution, it's directly proportional to the concentration and the length of the solution. This is called a Beer-Lambert's law. So here the instrumentation of UV, already we have discussed. The light source will be enter into the entrance light and touch into the dispersion element, hit into the dispersion element, and also the exit slit. So here the monochromator will be used. The monochromator works for using the beam of light will be converted into the single beam of light. So that single beam of light will be enter into the sample, and finally the detector will be detect how much of light will be the sample observed. So this is called the basic instrumentation of UV visible spectra. So here the same component will be separately we are discussed. So the main thing, entrance slit and colligating lens and dispersion device and focusing the lens, and finally the exiting slit. So U visible spectrometer is an overview. The sample will be the transparent liquid, because we can use in solid or liquid sample. We can take anyway, solid or liquid. If you liquid, it will be transparent. If you thick or some like a milky solution, we can't see the wavelength, because the light we cannot enter into the some colloidal solution. So it will be, solution will be transparent, the light will be passed to the transparent solution. Finally we can calculate the transmitted light or on the absorption wavelength. So in unveiling the multi-phased applications in UV visible spectro. So the UV visible spectroscopy, it's widely used in different industry and chemistry, biology, material science and environmental science, pharmaceuticals. So the lot of field we are using in UV visible spectra. And also UV visible spectra for medicine also we have used. So this is a basic principle we are discussed, and the instrumentation. The sample preparation will be, already we are discussed, the solution will be a transparent and data analysis. Application of UV visible spectroscopy we can used in various applications, and limitations and advanced techniques we are discussed. Thank you.